Morning, everybody. Hope everyone had a wonderfully restful weekend. I'm going to give everybody else just a couple more minutes here to log in. But before they do, and while we're waiting on them, what's the deal with you guys and your language assignments? You guys are having to read Midsummer Night's Dream or a book that's like a short version of a Midsummer Night's Dream, or what? Aha. Well, I went ahead and started downloading the actual play, and I got this like an original version alongside a modern, updated, like translated version. And I read it for half an hour, and I put it on my YouTube channel in case you guys want to go watch it. And man, this story starts out pretty dramatically. If you guys don't know the characters, um, I'm gonna mix them up now. So Eugeius is the daddy of Hermia, and he's telling Hermia she's got to marry Demetrius, but Demetrius is already in love with somebody else, and the reason we know that is because Lysander, who is clever, he's the one that's really in love with Hermia, and Hermia wants to marry him. Anyway, it's get pretty dramatic in the Act 1, Scene 1. I haven't finished it, the first scene, but it's been a fun read. Cameron, I had to mute you because I was getting a lot of feedback. It was like I was hearing myself out of your speakers.
Hey, Mr. Matthews.
Yeah.
Can you tell me what your YouTube channel's called?
It used to be called Math is Still Math, but then last year I was contacted by YouTube saying that they were cracking down on people having like multiple accounts, because basically I had like my primary YouTube account and then I made up this channel account. I think if you search for my name, let me see. I messed up my timer. One second. Boom, boom, boom. So when I go to my channel, yeah, right now it's just called Mark Matthews with one T. Tell me if you find it searching that way. Here, I'm gonna go ahead and kill this timer. Here, I'm gonna test something with Zoom here. Let's see if you can hear this or not. Can you hear that? Yes or no? Yeah, I didn't think so. So basically, even though you guys can't hear it, I went and got these little animated, like not animated, but I went and got these little pictures of the characters, so that anytime I was reading their lines or something was happening to them, I'd drag them in. So like, let me skip ahead in the video. Yeah, so it starts out with Theseus and Hippolyta, because Theseus is sort of like the duke of the town or the region or whatever, and he's getting married to Hippolyta. And I guess I thought that might be the main story, but it is not. So right now, Theseus is having to make this decision because click forward. Yeah, here's this love triangle. Okay, so basically, Egeus is the daddy of Hermia, and Hermia is in love with Lysander, but Egeus wants Hermia to marry Demetrius. And he's telling the Duke, like, hey, listen, if she won't marry the guy I want him to, she needs to be put to death because that's the law. Yikes. And so then Theseus, who's the Duke, is like, okay, Hermia, look, you better think about this, make up your mind, because in 4 days I need to hear what you choose. You can either choose to marry Demetrius because that's what your daddy wants. You can um, choose to die because your dad says that's the law, and it is. But you know what? I guess I'll give you another option. If you want to go live in a nunnery and never have a family, you can do that too. And I was having to wonder, man, what is wrong with Demetrius that she would actually ask? Is there, if I didn't choose to marry him, do I have to die? Is there a third option? But Lysander's clever and funny. He makes fun of him, saying that Demetrius, since Egeus loves Demetrius so much, he should just marry Demetrius. And anyway, it's a pretty. I thought it was really interesting. Now I had to go back and forth reading the translated version to really understand what was going on, but still, it's a pretty decent story. So yeah, if you have to read 30 minutes a week or 30 minutes a day or whatever, you might be able to cheat on that a little bit and just watch me read the story. But it's good. Yeah, and it finally gets back to Hippolyta, who's been standing there like the whole time. And anyway, so yeah, if you want some Midsummer Night's Dream, I'm putting that on my channel too, because reading is fun. Okay, so let's talk some math. So this week, we're gonna be talking about rates and proportional relationships, and we are gonna start today's session with this. I'm gonna zoom in as much as I can. Get you to be able to see it. Okay, so the rate or the speed of a function is how much it is increasing or decreasing depending on its inputs and outputs. Those are x values and y values. Looks like we have a little situation here. You're driving along an open highway on a cross-country road trip, cruising at a steady speed of 60 miles per hour. Okay, so what you need to understand is that when you see these words, a steady speed, right here, steady speed of 60 miles per hour, that's a rate. What is the slope of the line representing the relationship? Okay, so this is sort of a lesson in semantics. What I mean is these are words that all mean the same thing. So when it says the word slope, rates and slopes are the same thing. Slope is just like the visual representation on the graph of what a rate is. So what Colin's asked me to drag this line around and make a rate of 60 miles an hour. Oh, my lines are all going to move. Let me see if I can line everything up again. Okay. So the slope. Okay, so first of all, the first thing you have to do in this lesson is drag. I'm gonna drag this first dot way down here to the origin at 0, 0. And this next one, I'm gonna drag. Okay, so it says 60 miles per 1 hour. Graph the proportional relationship d equals 60t that expresses your distance traveled d in miles in terms of t in time in hours since you started going 60 miles an hour. Okay. Reading that can be a mouthful, and you might get discouraged reading chat. You might get discouraged because of the way it reads, like graph the proportional relationship of d equals 60t that expresses your distance traveled, and you might get lost in all the words and think, oh, this is hard. It's not. So if we're going 60 miles per hour, so after so these are hours and d for distance. So basically after 1 hour, we would have gone 60 miles. And after 2 hours, how far would we have gone after 2 hours? Look in the chat. How far would we have gone after? Yep. I see the answer is rolling in. It'd be 120. So that's the rate. If it's 60 miles for 1 hour, that'd be 120 miles for 2 hours, and so on. So I'm going to adjust the line here. So I can put this dot at either. These numbers at the bottom are time. So 1 hour, you'd go in 60 miles. Now this chart doesn't even go up to 120, so I'm going to go ahead and put it here. So there's the one, so that's 1 hour, 60 miles. And the slope is the rate. It's 60 over 1. So let me clear out my drawings. We'll try one more. Okay. Graphing proportional relationships. So now they've given us a little table of information. Let me try to zoom in on this part a little bit. It says, if a proportional relationship is shown in the table below, what is the slope of the line that represents this relationship? Okay. Well, my brain is instantly doing 3 different hop, skips, and jumps to figure this out. So let me try to break it down. When it is asking for the slope, just like in our last problem, what it's asking for is the rate of change. Now we don't have, now you could make a picture. Excuse me. We could draw the picture, do the graph first, and then just look at that. But they've given us this lovely set of numbers to work with. So a few different ways we can handle this. Now, since they gave us, let me show you what I'm looking at. Okay, so that's not what I wanted. I want a different color. Okay, so they gave us this little table of information, which means these are going to be coordinates on the graph. These are x values and y values. So these are going to be dots that I'll actually put on the graph. And if I'm imagining this in my mind, I'm seeing a y-axis and I'm seeing an x-axis. And these are decimals, so apparently the x values, which is the sideways line. So we're going to be going, 1, 2. Oh wait, this is skip counting. Let me back that up. Get rid of that. Okay, so this is going to start at 0, then it's going to go to 3, and then it's going to go to 6, then it's going to go to 9, and then it's going to go to 12. And these y values are going up very slowly. So at 3 over, we're only going up by half. And then so these keep going up by half each. Okay. So I'm not going to do the whole graph because I'm going to do that down here in a minute. But the point is, when x is equal to 3, y is going to be equal to 0.5. And when x is equal to 6, y is going to be 1. And when x is equal to 9, y is going to be equal to 1.5. And you can see the line sort of forming. And it already told us there'd be a dot at 0, 0. So it's not a bad little drawing. Anyway, so we're going to have a line that looks something like this. So the question still remains, what is the slope of this line? Okay, so the rate of change. How much did it go up when we moved over to 3? It went up by half. And then it went over 3 to get there. So what you need to remember about slope and rate of change, the way we write it down, it's always going to be answered, the rate of change, the slope, it's always going to be written as the change in y over the change in x. This little delta triangle symbol just means, it's a Greek letter that means the change in. How much is it going up and how much is it going over? That's what it's asking. The change in y over the change in x. So this guy was going up 0.5 every time it went over 3. That's the slope. It's going up by half, and I gotta admit, that 5 looks like a 6. Hang on, let me see if I can make that look better. It's going up, come on, pen. It's going up by half every time it goes over 3. So, I wish I could drag this with the website, but oh well. So that's my slope. Now, Com might spit that back to me saying it wants me to simplify in some way or whatever, but we'll see what happens. I guess you know what another way to write this would be? When we go over by 6, it went up by 1. I wonder if that's the one they'd prefer me to say, because decimals and fractions can always be kind of meh. But these are both the same. You know what? We're going to leave it like that and see what happens. But yeah, 1/6 would also be an acceptable answer. So let's go down here and manipulate this graph a little bit. So this needs to go to 0, 0. And then when we were at 6, it was at 1. Let's see what that says. Okay, it's telling me check my answer. Let's try this. See what happens. So I was right. So the first answer wasn't wrong, but they would prefer not to have decimals. So saying the slope was 1/6, they prefer that more. Okay, we're gonna move on to something a little bit different now, unless anyone has a burning question. The assignments are due. The graded assignments are due by Friday at 3 p.m. But if you want me to check them and give you some insights so you can correct some answers, I need them by Wednesday at 3 p.m. Okay, so we will do more of these another day. Let's look at this kind of problem. So we're still talking about rates and proportional relationships, but instead of a graph, we get sort of a story here. Andre loves to bake, and plum tarts are his specialty. Plums are on sale want to make sure I'm cubing this. Plums are on sale for $3.25 for 2 pounds. Yeah. You know, I don't think I'm a circle guy. I'm going to do boxes. $3.25 for 2 pounds at the farmer's market. At the supermarket, plums are being sold according to the following equation, where P is the price in dollars and L is the pounds. Okay, so we've got two different places. So we've got the farmer's market and the store. Why don't I make the store a different color? Where do plums cost less, at the farmer's market or the supermarket? Oh, okay. So we're comparing rates to see which one's cheaper. This is something you guys do all the time, or at least you should. Try and save yourself some money. Okay, so we need to compare these rates. So right now, I know that, okay, so P is the price in dollars and L is the pounds. Okay. So if we're talking price per pound. Okay, so we're talking money and pounds. Okay, so what this little piece of information is saying is that it's $1.75 for every 1 pound. So every time you get more than a pound, you have to multiply it by $1.75. So the question is that cheaper or more expensive than the farmer's market? Why don't you guys go ahead and take a guess in chat? Is that, which one's cheaper, the farmer's market or the grocery store, the supermarket?
The farmer's market.
We're gonna test it. Answering chat real quick. Okay, so there's a couple ways we can do this. What we need to do to compare them is to have the same number of pounds. So we can either divide the farmer's market side so that we can check 1 pound versus 1 pound, or we can just multiply the supermarket side and compare 2 pounds to 2 pounds. Now, I'm of the opinion that multiplying is just the easier mechanic. So what if we just said, okay, well, what if we were changing, how much would it cost to buy 2 pounds of plums at the supermarket? So let's just double both. It's called it's a proportional relationship. So if we're going to double the pounds, we have to double the price. So what's 1.75 times 2? Look in the chat. What is 1.7 times? What is $1.75 times 2? $3.50. It'd be $3.50. You get one double is $2, and 75 cents doubled is $1.50. So it'd be $3.50. Whoa. $3.50. So if we're trying to compare, apples to apples here, I think Cameron or whoever said it was right. Where are these plums more expensive or less expensive? Can anyone explain it?
They're more expensive at the farmer's market.
Are they? Right now, well, if we're trying to compare this, let me see. So at the farmer's market, it's $3.25 for 2 pounds. And at the supermarket, it's $3.50 for 2 pounds. So it looks like they're cheaper at the farmer's market. So let's see, let me clear all this math away and see what the question actually said. Where do plums cost less? And we just figured out they cost less at the farmer's market. Let's see what this one, we got a graph on this one. Okay, so we can't manipulate this graph, but we can look at it. The unit rate of change of y with respect to x is the amount y changes for a change of 1 unit in x. Okay, that is a math textbooky way to confuse you. The unit rate of change of y with respect to x is the amount y changes for the change of 1 unit of x. Oh my goodness. That is the most complicated way I've ever heard to say that, hey, okay, the rate of change, we're talking about the change in y. How much is this graph going up over the change in x? How much is it going over? Is the unit rate of change of y with respect to x greater in the equation y equals 0.25x or in the graph below? Okay, so this is just like the farmer's market problem, except it's really abstract. Instead of comparing prices, it wants us to compare these two rates. So let me clear this way real quick. Okay, so here's an equation. Part of this lesson requires you understand where the rate is, and it's right here. This number. 0.25 is the rate of this equation. So what we want to know is that more or less than the graph below? Is the unit rate of change y with respect to x greater? Okay, we're looking for which one is greater. Okay, so let me go ahead and scroll down a bit. So what we need to do, chat, is decide which one is more, because the equation from up here on my screen was 0.25. That was the rate of change. That was the slope. And I guess to answer that, we have to decide, well, what's the rate of change of this one here? So it's tough to tell right at 1 where that is. So what we're going to do is we're going to look on this line for a place where it actually does crisscross, and I think it's right here. So it's going from 0, 0 to 5, 1. So what we saw here is, let me do this in red because the line is red. So this goes from 0, 0 to 5 over and 1 up. Okay, so that means all right, Chad, I got the email, thanks. Okay, so okay, so to get this, okay, so the change in y over the change in x. So this one, every time it goes over by 5 units, like if it goes over 5, it goes up by 1. That's what we just learned by looking at this picture. If it goes over 5, it goes up by 1. And it repeats that process forever. It goes over 5, up 1, over 5, up 1, and so on. So the question is, which one of these is more? 1/5 or 25 hundredths? And to do that, we need to decide, and I'll let Chad decide, do we want to compare this with decimals or compare it with fractions? Chad, sound off. How do you want to compare it? I can do it either way. Decimals Unless everyone starts chiming in, they love fractions. We'll go ahead and do this with decimals. Okay. So that means we need to convert this fraction into decimals. So let's do that. How many times can 5 go into 1? It can't. How many times can 5 go into 10? Anybody else? I got the person giving me those answers is in private. I don't know if you knew that. Anybody else? I got one answer that's right. How many times does 5 go into 10, division-wise? Twice. 2 times 5 is 10. No remainder. Okay, so the slope, the rate of change of this red line is 2/10. The slope of that equation was 25/100. So which one is more? The blue 25/100 or the red 2/10? You could always imagine there's a 0 here, so 25 is more than 20, so 25/100 is more than 20/100. So the answer to this one, the equation has the greater slope. Okay. We've been going about for 30 minutes, and I think we're going to start looking at questions that are much more like the ones on your assignments. These are really important to understand, but I want to change gears just a smidge. Because the bulk of your assignment's going to look more like these, like this one. Okay, if you've got paper and pencil, now would be a great time to really start. Like on the other ones, I understand there were graphs, you don't want to draw a graph, but on these, paper and pencil is going to make muscle memory. You got to get good at these. Okay. For questions like these, okay, so it says, which ordered pair is a solution? First, we got to talk about what that word means. Answering chat. Okay, so how do we solve for what it says? What is the solution? Well, I guess you should understand what it means in this context. The solution is whenever you plug in numbers that makes this statement true, and by that I mean this. Okay, so true or false? 3 equals 3. I'm hoping your first response is to say that is true. And I'm pretty sure if I said true or false, 3 equals 7, you would say false. So solutions will always make sentences that are true, where one number is equal to the other number, okay? So that's just the vocab. The solution is an answer that makes the sentence true. Now, they are going to give us some numbers to test. So we've got this equation, and we've got these two sets of numbers. So here's the equation, and we've got this set of numbers and this set of numbers. And what we're going to do is we're going to test them to see if they make this statement true. I guess it's also really important you guys understand, and I'm hoping everyone knows this, but when we look at coordinate pairs, that's an x value, and then it's a y value. So what we can do is we can rewrite this equation using these coordinate pairs, and we'll see if it comes out to be true. Okay, so what's the y value? It's 15. Now again, look, the equation over here is y equals 7x minus 2. So y in this instance right here, look over here, there's a 15. So 15 equals 7 times what's x? It's right here. That's the 3. 7 times x minus 2. And now we need to decide if this is true or false. Remember, the definition of true means that both sides equal each other. So what is 7 times 3? Okay, chat sounds off. 7 times 3 is 21. Well, what's 21 minus 2? Is it 15? Yep, so I can't accept this answer. 21 minus 2 is 19, and 15 does not equal 19, so it's false. I guess so. I guess we're hoping that this other one works out. Maybe it will, maybe it won't. So again, this is our x value, and this is our y value. So we're going to rewrite the equation as y, which is negative 10. So negative 10 equals 7x. So 7 times x, which in this case is negative 1, minus 2. Okay, well, what is 7 times negative 1? That'd be negative 7. And what's negative 7 minus 2? Negative 7 minus 2 is negative 9. Is negative 10 equal to negative 9? So neither one of them worked. So they are both bogus. So I would actually end up picking neither on this one. And they give you a full explanation if you want to see it. So I want everyone to try this on their own paper. I'm gonna get you started, but I'm gonna give you a minute to give it a try. So what you're gonna do is you're gonna take this equation right here, and we're gonna use it twice. You need to test it with these numbers, and you need to test it with these numbers. So I'll go ahead and leg you up and show you what I mean. On your paper, you need to write down this equation with these values. So this is the x value, this is the y value, and then below, this is the x value, this is the y value. So when you write them, this one would be y equals 8x plus 3. So that would be 11 equals 8 times, and our x value is 1, plus 3. Then on the lower one, you're still going to, okay, so y value is negative 5, so it'll be negative 5 equals 8x. It'll be 8 times x, which in this case is negative 1, plus 3. All right, take a minute and see if A is true, B is true, both are true, or maybe neither is true. Go ahead and try that real quick. Give it another couple of seconds. Just updating a spreadsheet while you keep working. Okay. Cool. Getting answers via chat. Awesome. All right, all right, all right. So let's test them. Well, 8 times 1 is 8. And 8 plus 3 is 11. So I think this one's true. Now this one, 8 times a negative 1 is negative 8. Negative 8 plus 3 is negative 5. I think they're both true. Because you're at negative 8 and then you come up 3, you'll be at negative 5. So as far as I can tell, they both work. Yep. So I guess one of the issues you might have there, if you are kind of hit or miss when it comes to negative numbers, you might get caught on some of these where you knew the mechanics, but you goofed up on adding, subtracting, multiplying with a negative value. So I hope that that doesn't come back to haunt you. Okay. I would like to close today with one more kind of problem. Completing solutions to 2 variable equations. Okay. So again, this is a big, big, big paper pencil sort of practice. Because it just says complete the missing value. So let's see what they give us. So we've got an equation here. And then they give us some information down here. So the question is, what did they really tell us here? Well, I noticed straight away that because I know that this is an x value and this is a y value, when it asks me to complete this equation, what I'm really searching for is the missing y value. But they gave us the x value. So here's what you end up doing. We're going to do this exact same equation, but since they gave us what x is equal to, we can substitute in the x value. So we don't know what y is, so this is still going to be, so this will be y minus 3 equals 2 times, and this is where we put in our x, negative 1 plus 1. So this guy right here, this negative 1 for the x value, we substitute in right here. You can see where the x is in the equation. So I just rewrote the exact same equation, except I put in the x value I wanted. Let me scoot this over a bit. Not too much. Okay. Yeah, that works. Okay. So now I'm just going to do a little bit of arithmetic. Y minus 3, can't do anything with it yet. So this is still y minus 3. But I can't do what's in parentheses here. So what's negative 1 plus 1? What's negative 1 plus 1? This is a rule. Whenever you add opposites, what do you get? What's negative 1 plus 1? 0. Now, 2 times 0, we still got this y minus 3 going on. Now, 2 times 0 is just 0. Now, here's where we do some inverse operations. So what's the opposite of subtracting 3 is to add 3. Let me do a different color for this. Hang on. This is important. So I'm going to add 3 to both sides. No one told me to do this, but I know this is going to help me get the answer. I'm going to add 3 to both sides. So when you add 3 to a negative 3, you're adding two opposites. That makes 0, and that's what we wanted. We want to have y all by itself. Now 0 plus 3 is 3. So, there it is. So after we substituted in the x value, did some basic operations, and then we thought of this inverse operation to get y by itself, we find out that y is equal to 3. And that's how these work. We've got about 10 more minutes, so I'm going to continue doing these because these are probably the most technical, I think, as far as just straight up arithmetic goes. Check the email real quick. Okay. So chat, try this one. Even if you forgot from 2 seconds ago what we just did, it's fine. I still want you to try. So go until you hit a speed bump and don't know what to do next. So here's our equation. Here's the value they gave us. So the first thing you need to realize is what this is. They gave us the y value. And what we need to complete this the coordinate pair is we need the x value. So here's what I want you to do, chat. I want you to try and rewrite this equation, but instead of having a letter y here and here, I need you to plug in the y value that they gave us. So go ahead and try that real quick. Okay. You should all be ahead of me, but I will start. Okay, so this would be, type it. So it'd be 6x plus 7 times our y value, which is -4, equals 4x. I'm going to run another room with this font. Do it down here. Plus 4 times our y value, which was -4. Still ran another room. Okay. So all we did was we took our y value of -4 and plugged it in. We substituted it in wherever there was a y value in the equation. And now we just have to do some arithmetic. So this is still going to be 6x. 7 times -4 is -28. This is still going to be 4x. But this would be plus 4 times -4 is a -16. Okay, so now we've got a bunch of options, but what it's going to come down to is more inverse operations to try and balance the equation. So my first instinct is that I want to get all the x's on one side of the equation. So what's the opposite of a positive 4x? It's a negative 4x. And whatever I do to one side, I'm going to make sure and do to the other side. Okay. And this is why I wanted to focus on this lesson at the end of the video, because this is where you really need to focus your technical skills and attend to precision the most. I'm going to condense some steps here. So I also want to move this 28 to the other side. So what's the opposite of adding a negative 28? Adding a positive 28, but whatever I do to one side, I have to do to the other side. So let's see what I end up with. Now, no one told me to do that, but I instinctively knew that if I want to start getting these numbers together, I'd have to move them around with some inverse operations. So let's see, where are the cancels? Okay, so negative 28 plus 28 makes 0, so they cancel each other out. 4x minus 4x makes a 0. They cancel each other out. So what I end up with, 6x minus 4x is 2x equals negative 16 plus 28. Again, integer rules. You have to be good with negative numbers. So adding a negative 16 and a 28 together is the same as 28 minus 16, which I believe would be 12. 28 minus 16, 28 minus 10 is 18. 8 minus 6 is 20 minus 10 is 10. 8 minus 6 is 2. That's what I meant to say. Yeah, it should be 12. Now, if 2x equals 12, back to my inverse operations, I can divide both sides by 2. And what you end up with, 2 divided by 2 is 1. So what you end up with is that x equals 6. Because 12 divided by 2 is 6. So apparently whenever y is equal to -4, x is equal to 6. Practice, practice, practice. You got these lessons for a reason. Now you have 2 assignments posted on Classroom. They're literally called Assignment 3 and Assignment 4. They're due by Friday at 3 p.m. If you get them into me by Wednesday at 3, I can check them and then let you know if there are corrections to be made. Let me see. I'll remind everyone in chat or anyone watching on YouTube that I have started a little series on your Midsummer Night's Dream that you got assigned by Miss Elliott. Now, I don't have the exact text you guys have. So I went and found the original plus a translation. So if you're having trouble understanding the story, or if you're required to read so many minutes a day or a week, whatever, and you just want to check in with mine, and maybe Miss Elliott won't care that you're reading along with me, feel free to look in on that. But I hope everyone is healthy. I hope everyone's taking care of themselves. I hope everyone is making their beds every day, because you'll have a better day if you make your bed. But we got 2 minutes, so unless someone has a question or concern to mention, we are done for our Monday.
I have a question.
Yeah, what's up?
What did I make on last week's Google Classroom post?
I was putting the grades out last night, and then I started feeling really crummy, so I went to bed. So if you haven't gotten yours, you will have it later today as soon as I'm done with my video streams.
Okay, thank you.
Yeah, no, I'm sorry. I meant to get it done last night, and I just started feeling horrible, so I went to bed. So most people have their numbers, and if not, it'll be posted here after I stream for 6th period.
Happy Easter, Mr. Matthews.
Yeah, happy Easter, guys. We did Easter eggs in the morning before it started raining, and little one is still finishing all her candy. I had a few pieces too, so I felt really guilty about that. But you know what? You gotta live. You gotta live. So I'll just do more elliptical and work out.
I was eating candy during your stream.
Thank you. Now we know that. What is your Easter candy of choice?
Snickers and Milky Way.
Mm-hmm. You know, that was the thing. Okay, so chat, we'll chime off. We'll end with this. What do you guys prefer? What's your holiday? Easter or Halloween?
Halloween.
See, I disagree. As far as from the kid perspective, taking the religious aspect out of it, when you're talking about just candy, I understand that Halloween is the candy holiday, but Easter is the chocolate holiday. And I don't know why that is, but a lot of the candy sometimes you get on Halloween is not the candy you prefer, but I have never been disappointed by Easter candy because it's always chocolate.
I can't eat that much chocolate.
I got Sour Patch Kids and Reese's.
Mm-hmm. That sounds like a gross combo.
I got a new.
Go ahead. All right, guys. Well, that's going to do it. We'll do more practice problems tomorrow. Take a look at the classwork. And if you're having troubles with it, bring screenshots with you, and we'll go from there. Take it easy, guys.
You too.